Hi everyone. Today we are going to be solving problems involving acute triangles using the sine law. Go ahead, grab a piece of paper and a pencil, and let's get started. What do you notice about the triangles below? The first thing that I noticed, if I look at the angles in question A and B, and if I add up the interior angles of the triangle, so 51 and 71, and then I subtract from 180, I know that I don't have a right angle. There's no 90-degree angle at C. So this is an acute triangle. And also if I look at B, I notice the same thing. If I add 22 and 39 and I subtract that from 180, Y is not 90 degrees. So these are not right triangles. That makes these acute triangles. Okay, let's write that down. Something else that I noticed, if you look at the first example here, part A, we have angle, angle, side. And in the second example, we have angle, side, angle. Okay, next we're going to look at the sine law formula that will help us find any missing side lengths or missing angles in an acute triangle. There are two versions of the sine law formula. One version is if you are looking for side lengths, and the second version is if you are looking for angles. They're basically just the reciprocal or the flipped version of each other. Let's go ahead and take a look. So if we are missing an angle, we want to write the ratios. So because there's three sides of a triangle, we are going to have three ratios in our formula here. So sine A, and our A is going to be capital over lowercase a, is equal to sine B over lowercase b over lowercase c. And then if we're missing a side length, we reverse the formula or flip the formula, or think of it as the reciprocal formula. So the side lengths, remember when we're labeling a right triangle, are denoted with lowercase, and angles are denoted with uppercase. We're going to talk about that next. So A over sine capital A is equal to B over sine capital B is equal to C over sine capital C. So the other thing that we observed in the previous two examples is that we had an angle side angle, and the other option was angle angle side. In those two cases, we are going to use the sine law formula. Okay, let's take a look at labeling triangles. So just to recap, we're labeling triangles with capital letters to denote the angles and lowercase letters to denote the side lengths. So in this particular example, capital A, capital B, and capital C all denote angles. And lowercase a, lowercase b, and lowercase c all denote side lengths. So in order to use the sine law, we need one known side that is opposite of one known angle. Okay, let's take a look at our first example. Calculate the missing side length, and we're going to round to 1 decimal point. So for this example, we're looking for side length x. So we are going to be using the ratio for the side lengths. So we're going to look at A over sine A equals B over sine B equals C over sine C. So we're going to be using the ratio A over sine A is equal to B over sine B is equal to C over sine C. So we actually only need two of the ratios. We don't need the third one. And in this case, we have an x. So if you wanted to replace the A with x, you could do that as well. So I'm going to be using side length x and 80 for my first ratio. And my second ratio, I'm going to be using 7 and 60 degrees. So if you notice on the diagram, it kind of makes like a little X. I like to think of it as X marks the spot, or maybe you think it looks like a little butterfly. I don't know if you kind of imagine that you drew little antennas. Anyway, so you can think of it however you like. So I'm going to think of it like X marks the spot. So for my ratio to fill it out, my side length, X, is going to divide by sine of my angle that corresponds with that side length. So X over sine 80 is equal to 7 over sine 60. And now we're going to solve for X. So I need to undo the division of sine 80 that's underneath the X. So in order to undo division, I'm going to multiply both sides by sine 80. So in other words, what I'm going to be doing is I'm going to be moving that sine 80 right up next to the 7. And I'm actually going to put it in behind the 7. So X is equal to 7 times sine 80 degrees divided by sine 60 degrees. So we're going to go ahead and plug this in on the calculator. Some of you, remember, might have to plug in the 80 first. Typically, we plug it in just as it appears from left to right. 7 times sine 80. Sometimes you might have to press equals in between. I like to press the equal in between the numerator and the denominator. So 7 times sine 80 equals, and then that answer divided by sine 60. Some of you on your calculator will have to key in 80 sine times 7 equals divided by 60 sine. So it just depends on how your calculator works. So go ahead and give that a go, and I'll put the answer down and we'll see if we get the same answer. And remember, we're rounding to 1 decimal point. When I plug that into the calculator, we get 7.99, so we're going to round that to 8.0. And our units, we're not given units in the problem, so we can just write out the word units. And so remember, that's for the side length. Okay, let's take a look at our second example. Looking at our second example, we have angle, angle, side. So 88, 35, and 44 are given, and we're looking for the X. So the X corresponds with this missing side length over here that we don't know. And then the 88 degrees corresponds with the side length of 44. If it helps you, go ahead and label your triangles. I know these triangles are not labeled, but if you want, you can label A, lowercase a across from it, B, lowercase b across from it, capital C, lowercase c across from it. So if that helps, go ahead and label your triangle. Okay, so we actually need to figure out the missing angle at angle C. So in order to do that, we know the interior angles of a triangle add to 180 degrees. So we're going to go ahead and subtract 88 and 35 from 180. So angle C is equal to 57 degrees. So now we can use our ratio. So X over sine 57 degrees is equal to 44 over sine 88. Okay, we're going to multiply both sides by sine 57. So X is equal to 44 times sine 57 degrees divided by sine 88 degrees. Okay, go ahead and plug this into your calculator and remember to round to 1 decimal point. So this time we get 36.9, and for good communication, we're going to include our units, millimeters. So the missing side length is 36.9 millimeters. Okay, let's look at our next example. So in this example, we're going to calculate the missing angle this time, and we're going to round to the nearest whole number. So same idea as before. If it helps to go ahead and label your triangle, please do so. You can have A, B, C, X, Y, Z, any letter you would like. So across from angle A is lowercase a, B is lowercase b, C and lowercase c. So my angle that has the 51 corresponds with the side length that is the 9.4, and X corresponds with side length 6. So again, it kind of makes a little X there. If you can tilt your head and kind of imagine it makes an X. Okay, so angle X, so that means we're going to use sine X over 6 is equal to sine 51 degrees over 9.4 centimeters. I don't need to write the unit. Next, we're going to remove the 6 from the denominator by multiplying both sides by 6. So I'm going to put the 6 in front of the sine 51. And then I need to isolate x. Right now I have sine x. So what I'm going to do is I'm going to take the inverse sine function in order to determine the angle x. So I'm running out of space. I'm just going to write that up here. So x is equal to sine -1 or sine inverse of 6 sine 51 degrees over 9.4. So when you're plugging this into the calculator, you're going to have to likely enter the bracket part first and then press equals and then shift or second sine. So on my calculator, I'm going to plug in 6 times sine 51 equals divided by 9.4 equals, and then shift sine or second sine on your calculator. Okay, go ahead, plug that in and see if we get the same answer. So after plugging it in, I get x is equal to approximately 30 degrees. So remember, we are rounding to the nearest whole number. So 30 degrees. Okay, next example. Okay, so looking at our next example, we have an unknown angle across from a known side length. So we can figure this one out here. And we have a known angle across from a known side length. So again, we make our little x. Okay, so we have sine x over 22 is equal to sine 42 over 17. And again, we're going to multiply by 22, and then we're going to take the inverse sine function. So I'm going to do that all in one step this time. Okay, let's go ahead and plug this into the calculator. So x is equal to, so on your calculator, 22 times sine 42 divided by 17, and then shift sine. So x is equal to 60 degrees. Okay, one more example to go through. For this example, we are going to solve. That means we have to find all missing angles and all missing side lengths. And we're going to round to 1 decimal point where applicable for side lengths and nearest angles to the nearest whole number. Okay, so angle C. So 180 degrees, take away 51 degrees, subtract 71 degrees. So angle C is equal to 58 degrees. Okay, so 58 degrees, I can write that in there. And so just labeling the triangle, so we need to find side length B and side length C. So I can start with side length B. So B over sine 51 degrees is equal to, I'm going to use the ratio that I'm given both the angle and the side length. So 9.4 0.8 over 71 degrees, sine 71 degrees. So just make sure you are being consistent. So we want the missing variable up in the numerator, and we want to make sure that, so if we are looking for the side length, both numerators are side length and both denominators are angles. Okay, let's go ahead and solve for B. So B is equal to 9.8 sine 51 degrees divided by sine 71 degrees. Okay, go ahead, plug that into your calculator, and we're going to round to 1 decimal point if necessary. So B is equal to approximately 8.1 centimeters. Okay, next we're going to find C, side length C. So for side length C, C divided by sine 58 degrees is equal to, again, I'm going to use the same ratio, the 9.8 over sine 71. So C is equal to 9.8 sine 58 degrees over sine 71 degrees. And again, go ahead, plug that into your calculator and round to 1 decimal point. So C is equal approximately 8.8 centimeters. Here's a couple examples for you to try on your own. That's it for today. Thank you very much for your attention. Bye-bye.